Ma'am, 2 minutes,
Okay,
ma'am.
okay, I will wait.
Good morning to everyone. I welcome everyone for the second session of second day of ATAL FDP program. I welcome everyone, and it is my honor of welcoming our resource person, Dr. S. Vijay Chitra Madam. She is professor and head of the department of E&I department in Congo Engineering College. She completed her UG, BE, Electronics and Communication Engineering from Mohambique College of Engineering with a credit of first class. After that, she completed ME in the field of Process Control and Instrumentation Engineering from Annamala University with an honor of gold medalist and distinction graduate. After that, she completed a doctoral degree in the year 2009 in the field of Studies on Process Modeling and Optimization from Anna University, Chennai. She started her career as a lecturer in the year 1994 in MPNMJ Polytechnic College, Chennai, up to 2000. After that, she started her career from in Congo Engineering College as lecturer in the year 2002. Now she is professor and head of E&I department. She has published 109 scope indexed journals, national and international journals, and she has presented various papers in 51 international conferences. And she presented the papers in 33 national conferences, and she published 6 books, and she filed 3 patents, and she published 8 monographs, and she delivered 87 guest lectures in various STDPs, FDPs, workshops, seminars, and etc. She has received 48 fundings, and she has participated in 51 conference and short-term courses. She has completed 3 NPTEL courses and secured very good scores. And she received various honors and awards like Best Staff, Senior Woman Educator and Scholar, Best Outstanding Researcher, Best Professor, and Excellence Award she has received. And she has undergone 5 industrial trainings, and she has guided many students under her guidance for completing their doctoral degree. She was a receiver for 6 various indexed annexure journals, and she received a grant, travel grant, and for 3 various fundings. And in her career, she has handled 22 UG and PG papers, and she was a member of scientific and professional society of various professional bodies. And she have completed consultancy works in Malco Peoples and IEPCL, and she is Satish Textiles Kumarabalayam. She has visited Singapore for the purpose of paper presentation in IEEE conference. She was a board of study member for Kumaragaru College of Technology, Karpagam University, Adiyaman College of Engineering, KSR College of Technology, and Mahendra Engineering College. She chaired a session and she acted as a jury of various 14 conferences, and she is an approved supervisor of Anna University of Technology, Coimbatore, and she is an approved supervisor of Anna University, Chennai, and number of scholars awarded 10. Presently, 7 research scholars are doing PhD under her guidance. She guided 46 UG projects and 34 PG projects, and totally 17 PhD scholars have done their project PhD work under her guidance. With this huge experience and huge academic excellent person we are having as a resource person, it is my honor and privilege and happy to introduce her in this forum. It was a great honor of having Vijay Chitra Madam as an resource person for our ATAL FDP sessions. Thank you, ma'am. Thank you for accepting our invitation, and thank you. Always you are supporting me in all my work. Thank you, ma'am. I welcome you, ma'am, once again.
Thank you, Shyamala. So very good morning to you all, the ATAL FTP participants and FTP coordinators, and my beloved and best friend ever, Dr. Shyamala Gauri. She is always in touch with me. Whatever the programs she is organizing, definitely I was a part and I will be a part of that program. So I'm very glad to be a part of all her activities. So I'm feeling proud to be a friend of Shyamala Gauri Madam. She continuously conducting such kind of FTP programs. Really, I should appreciate her for her constant efforts. So let me thank once again the organizers for having given me the wonderful opportunity to be a part of this FTP program as a resource person. So let me share the today's PPT. Deeptisha, please mute yourself. Shyamala madam, if you are having that control, you can mute him. Because it should not disturb others.
Yes, ma'am. I'll mute him.
Okay. Still, I'm having noise, Shyamala.
Ma'am, 2 minutes, ma'am. I'll do this now.
Okay.
कमी कसं काय होईल 29,000 करायला त्या नेचर 33 एवढे कट झाले त्या नेचर म्हणून सांग हा तिथं किती अमाऊंट आहे 29,600 मायनस करतात
Thank you for her response. Okay, Shyamala madam has given the topics. I hope you all have the session schedule. So I have consolidated the title as Electric Vehicles Charging Station Design and Requirements. So as madam, the coordinator introduced me, I am Dr. S. Vijay Chitra, currently serving as Professor and Head, Department of Electronics and Instrumentation Engineering, Kongu Engineering College. So after a long period, then I have finally attained this position with a lot of paper publication and projects, grant, etc., etc. So really, these parts made me widened my profile. So whenever any topic is given to me, I will definitely touch with a few slides about the basics. Then only I can come to the topic what I am going to handle. Okay. So here I have taken the electric vehicle charging station requirements. So before that, we have to know what are electric vehicles and why do we prefer electric vehicles and how do we do charging. So electric vehicles, I hope yesterday is the program started. So you hope you all know the fundamentals of electric vehicles. So electric vehicles, simply I will use EV in further slides. So they use some electric motors which are powered by electrical energy. So that electrical energy will be or was stored in a battery for propulsion. Okay, so we use the electric vehicle got powering from energy storage in the battery. These vehicles are available in variety of models with varying ranges and capabilities and are plugged into a source of electrical power to recharge. So initially they have developed an electric vehicle with a single range, single model. After undergoing lot number of tests, then they have extended their ranges and capabilities were also be extended. Now the electric vehicles are in huge usage. Okay. So, electric cars use stored chemical energy in battery. So, we all know, though they release it electrochemically without any kind of combustion. So, that's why we are preferring this electric vehicle. So, it can avoid the combustion. Okay. So, we can definitely be able to control the air pollution. So, there is no burning of any fuel. So, that's why there is no air pollution from the tailpipe. And also there are no emissions of any ICE, okay, any gases, polluted gases. So generally they are called as electric vehicles of different types. One is a BEV, battery electric vehicle, and second one is PEV, plug-in electric vehicles. And suppose if any of the vehicle requires both fuel as well as the battery, then they are called as hybrid vehicle. So hybrid cars, now many of the electric cars on the road today are actually of hybrid nature. Okay, we can have the utilization of both fuel as well as battery power. Okay, that's why hybridization of two technologies. That's why they are called as hybrid electric vehicle. Why EVs? Why do we need to use EVs? Okay, so there are certain advantages. Usually, we, the human beings, will prefer any kind of technology when there are certain advantages, right? So, advances in battery storage technology. So, once the power is stored in the battery, then we can utilize the battery storage technology for operating the vehicle. First one. Second one, lightweight vehicle construction. Okay, since the vehicle is of lightweight, less weight, then we can prefer. Suppose if the material or the vehicle or any motor which is of bulkier size, we don't prefer, right? So due to the less weight condition, compact size condition, then we can prefer. Third one, electric grid automation and other factors. So these three advantages will increase the attractiveness of the electric vehicles for any consumers, business people, and other government agencies which should support all time. Okay, so here in order to promote the usage of the electric vehicles and to provide more awareness about the advantages of electric vehicles, now government also nominated certain policies, government promoted certain schemes, government proposes certain rules and regulations so that they will attract the people to use. Okay, so there are more number of the consumers and business people which can readily buy the electric vehicles now. So that's why electric vehicles are now in demand. Okay, so these are all the reason behind the usage of the electric vehicles. And why do we need, we the technical persons should define the technical constraints for which we have to select the electric vehicles. Two things. One is the environmental concern and second one is practicality. So environmental concern. So here with the help of that is without electric vehicles, what we are using the conventional bikes, no, we have to use fuel. either petrol based. Suppose if it is of a car or heavy vehicle, then we have to use some diesel. So heat, for which we have to use the heat combustion engine. So which can definitely provide some unwanted gases as a cause for air pollution, so which may definitely lead to global warming. So this is the first environmental concern. So we need to overcome that drawback by means of providing electric vehicle, by means of avoiding that fuel based engines. This is the first one. Second one, so we all know now what is the price of the petrol engine, petrol nowadays. Okay, petrol, the price of the petrol is day by day increasing. So definitely, it will definitely lead to insufficiency. Okay, so current conventional cars use quickly decreasing the source of the fossil fuel. One thing, and second thing, the lack of usage due to the increase in the price of the fuel. Okay, so that's why practical concern is there. So we are in need to have an alternative. Okay, so that's why we have to prefer certain alternative, that is called electric vehicles. So when the electric vehicles evolved, okay, what is the basic history behind the electric vehicles? So in the year 1830 itself, first electric garage was built. So this is the first electric garage. So see, there is a battery at the bottom. So the power is stored in that battery. With that, the vehicle was run. Okay, so this is evolved during the year 1830 itself. So after that, during the year 1891, the first electric automobile was built in that state called United States. Okay, 1900 heyday is the name of the electric vehicle. And then 1908, Henry Ford introduces a Model T. So this is the model. This electric vehicle was just modified. Okay, so during the year 1908, there is a first modification done in the electric vehicle. In that vehicle, certain modifications was carried out. So after that, 1974, this is the modified electric vehicle. This is the name of the electric vehicle is called Vanguard Sebring. Vanguard Sebring. So this was also evolved in the country US. So after that, 1994 to 2000, maybe 3 years, there are thousands of electric cars were evolved, but they were not in plenty of usage. Okay, they were only available for lease. Okay, the usage is certainly limited. So in during the year 1998, another vehicle called GM EV1. So this is the vehicle evolved during the year 1998. So this is the picture of the electric vehicle introduced during the year 1998. After that, 2003, GM discontinued the EV1, and almost they have demolished the electric car, because the people don't like, this is like bullet cart. So the design itself not attractive for people. So that's why GM discontinued that design, demolished the electric car. After that, 2007, then Tesla Roadster. This is the name of the electric vehicle. So this is the picture of that electric vehicle introduced during the year 2001. So this was more attractive behind the people. So many number of the people who were rich in money, they were interested to buy that electric vehicles. So once they bought and used that electric vehicle, many of the people were ready to buy. Okay, so this is the history of the electric vehicles. Now after that, with the some more modifications and reduced price, now currently many number of the electric vehicles are in usage. Okay, so this is the history behind the electric vehicle. So what are all the parts behind the electric vehicle? See, these are all the four wheels, and at the bottom we have to keep that electric motor, and then high voltage battery, and there is a charger, and this is the controller. See, a charger, and then once it is plugged in, and then the power gets charged, and it can be stored in the battery, and then it can be sent to the controller, and the electric motor gets operated. Okay, so these are all the major parts of the electric vehicles. How do we position the battery in the electric car? So this is the place. So there are certain positions, so in which then we have to keep that battery. Okay, and it won't affect the comfortability of the people who are riding in that electric vehicle. See, the people were sitting inside the car as a conventional way of sitting, and this is the place in which the electric vehicle batteries were placed. Okay, this is the placement. There are two major types of the electric vehicles. One is the AEV, all electric vehicle, and second one is PHEV, plug-in hybrid electric vehicles. Okay, we will see one by one. So first one is AEV, all electric vehicles. Okay, so AEVs are powered solely by energy stored in the vehicle's battery system. So fully it can be operated only by the battery available at the vehicle itself. There is no backup power generation in the vehicle. Okay, so when the battery runs out of charge, it requires recharging before operating again. So due to the lack of availability of the battery, once we charging, then till the charge is draining, then we can able to run the electric vehicles. But once it can be completely drained out, then we have to operate after recharging the vehicle. So that is the drawback. Okay, so these are all the examples of all electric vehicles which are currently registered: Mitsubishi and Nissan Leaf, Tesla Model S, and Ford Focus Electric. So Ford, Nissan, Mitsubishi, Tesla, these four companies have developed the electric vehicles which are powered only by the energy stored in the vehicle's battery system. Okay. And this is the picture of all electric vehicles. See, this is the place of power electronics, and this is the electric motor, and there is a charging port. This is charging equipment. We have to connect this plug here, and this is the connector and port, and then battery. Okay, from which once the charge gets filled inside this battery, then it can be given to the controller and the other various parts. The motor gets operated in order to drive the car. And second one is plug-in hybrid electric vehicles, represented as PHEVs. So here they are capable on electric energy for certain distance, after which an auxiliary internal combustion engine is engaged in order to offer additional range. So there is a additional combustion engine along with this. Okay, so it can able to provide certain ranging. Okay, so and they are often categorized according to the range in the electric mode. So there are certain ranges can be operated by using these PHEVs. There are certain examples: Chevrolet, Ford, C-Max, and Fusion Energies, and Toyota. These are all the examples of the PHEVs currently registered. So if you take the Chevrolet, it can able to run almost 40-mile electric range. Okay, so the battery name is PHEV 10. It such as Toyota Prius plug. It has approximately 10-mile electric range. If you choose Chevrolet, then it can have PHEV 40. It can have 40-mile electric range. So depending each and we cannot tell all the electric vehicles are of same voltage and same mileage electric range. Okay, so depending upon the construction, depending upon the capability, then we can have a different mile electric range for different examples. So these are all the possible examples of the PHEVs that are currently registered. So, and this is the snapshot of the plug-in hybrid electric vehicle. These are various parts behind that. This is the fuel tank. This is the power electronics. There is a battery. So this is a hybrid one. It can able to operate both by fuel as well as the battery power. Then once we have to switch which one can be operated, then we have to switch. Suppose if the electric vehicle is first operated with the fuel, and once the fuel has drained, then we can switch into battery operated. So depending upon the user's requirement and which one is desired, then we can able to operate. And this is about the charging, similar to that. Okay, there is a port connector and charging equipment, power electronics, all other are similar to the AEV. So this is about the electric vehicle and how they have been evolved and what are all the major parts and what are all the different types of the electric vehicles. Now coming to our topic, how those electric vehicles have been recharged. Okay, so what is meant by EVSE? This is because recharging is the most important thing we need to study, because how it can be recharged and what are all the charging station equipments and piping layout, everything we need to consider. Recharging EVs, it is accomplished through connections to electric vehicle charging equipment, which is referred to as EVSE, that is electric vehicle supply equipment. Okay, suppose if we want to recharge the electric vehicle via this EVSE, then we can able to provide the recharging. So this recharging is able to provide the facility, because every vehicle should need that EVSE for operating. Okay, and this is actually a protective system which can able to communicate with the vehicle, as well as it can able to monitor the electrical activity in order to ensure safe charging. Because since this is of electrical vehicle, then we have to ensure the safety condition. Okay, user safety is very much important. Since it deals with some electronic parts, this is an electric vehicle, and definitely it should be ensured that it is a protective system. So while the actual charger is contained in the vehicle, then it can be referred to as a charging station or EVSE. It consisting of it can be called as conduit, control and monitoring device, and which can able to connect the vehicle to the electric grid. So via this, we can able to do monitoring, we can able to do control, we can able to do storage. So that's why EVSE is nothing but a conduit. Conduit is like a device, and then it can able to do both monitoring as well as control. So it can able to connect the vehicle to the electric grid. So this is the advantage of EVSE. So overall charging energy flow from the power grid through EVSE and into the vehicle. Okay, so it can be done by means of using a connector. So that is called industry standard J1772 port connector. So this is the standard connector. So that's why I can able to mention the number also. Industry standard J1772 port connector. So here with the alternating current AC, that EVSE charger electronics within the vehicle invert the AC power supplied by EVSE into DC current for storage in the battery. So whatever we are providing the AC current, so that can be converted to DC, and that DC current can be stored into the battery. So the power electronics can include the conversion of AC to DC. So fast charging DC EVSE delivers high voltage, typically over 400 volts direct current, straight to electric vehicles battery system. So because of this conversion, it won't provide any delay. So there is a fast charging system. So that's why that the 400 volt high voltage current can be straight away converted, and it can be stored into the battery system. So that's why we can able to assure there is a fast recharging system with the help of EVSE to any electric vehicle system. So electric charging station is an element in any structure that supplies electric energy for the purpose of recharging any kind of the electric vehicles, maybe plug-in electric vehicles, and which include electric cars and plug-in hybrids, etc. Okay, so it can able to provide both electric energy as well as recharging circuits. All the things have been available only at the electric charging station, which can be useful for any electric vehicles. So that's why, in order to get safety and perfect operation of the any electric vehicles, charging stations are very much inevitable part. And this is the electric vehicle ecosystem. Okay, so it can able to ensure error free, air pollution free control and monitoring and control. That's why we can say this is a part of electric vehicle ecosystem. And when coming to the India, with a road network of 54, 72, 100, 144, almost 54 million, okay, 72,144 kilometer, the country needs nationwide network of charging stations. Okay, so for electric vehicles, as government is planning to sell only EVs by 2030. So government is planning now, almost during the year 2030. Now we are at 2021. So one more, now 9 more years to come. So almost in the road, all the vehicles to be electric vehicles. So definitely we can visualize the current scenario. So we the people, the vehicle users, vehicle consumers are very much struggling in a fuel price. So that's why they would like to switch over to electric vehicles. So definitely it will be possible in future. And this is how electric charging will be there. So see, when we consider this is about the car, the back side, then there will be a battery, and this is the onboard charger. This is the plug. Okay, so here this part can be called as AC charging. So it gets electric AC current, alternating current, and every vehicle has an onboard charger, limited power and slow charging. After that, there will be a DC charging electronics. So infrastructure investment is shared among hundreds of users, large power rating and fast charging. So it is capable of having integrated with renewable energy sources like solar power, etc. So this is the DC fast charging station. Okay, so this is the solar energy possibly will be given. So once the fast charging station available, from which the power gets plugged, and then it can be stored into the battery. Okay, so we can have two categories. One is AC charging and second one is DC charging. So that AC can be converted into DC, and that can be further stored into the battery. So electricity from the grid is delivered in terms of alternating current, but we all know the electric vehicle always require a DC current. So we all know AC can be converted into DC by means of a rectifier. So a rectifier needs to place between the grid and battery in order to convert one to other. So suppose if it is of a smaller area like home, and there is a third party public charging, this AC to DC conversion can be done by electric vehicles onboard rectifier. There is a power electronic circuit available in the electric vehicles itself. Via this onboard facility, then AC can be converted directly into DC. So that AC current at this charge part can be converted to DC for the battery by means of the rectifier, which is in the circuit, electronic circuit. Okay, there are certain superchargers which deliver high voltage, maybe 400 volts, so high current DC electricity directly to EV battery without any conversion or without any usage of the rectifier. So it will bypass the onboard rectifier. So depending upon the type of the facility what we are preferring, the cost may vary. Okay, so suppose if the placement of the supercharger in the electric vehicle, then cost will definitely high enough, and we can ensure the fast charging, recharging. This allows the supercharger to push electricity into the battery as fast as the battery can take it. So almost 10 times faster than that of the home charging. So superchargers can able to recharge the battery 10 times faster than that of the normal chargers with the placement of the rectifiers. So normally we prefer the conventional charging with the help of rectifiers in the home and smaller area. If it is of a mall and it's a bigger area, then we have to provide the superchargers. If there is a parking area in which more number of the electric vehicles to be parked and needs to be charged, then we have to prefer supercharger in that place. So see, this is about the EV public car station. Okay, electric vehicle public car station. See, here there is a solar panel. So that solar panel can be put as a roof like that. And here this is the station in which there will be certain plugs are there. So see, each and every parking slot can have that plugging. So once the car has set and stopped in that slot, and when it needs, then it can be plugged in and charging will be happened. Usually, when any businessman wanted to do recharging during his parking area, parking slots, then definitely it can be carried out. So since they don't want to waste their precious time, business timing, okay, so at that time they can able to utilize the public car station. So here in that public car station, it is better to prefer the super chargers. Then they can able to deliver the charging fastly without conversion of the AC into DC. Directly it can able to charge. Okay. And it is 10 times higher than that of the conventional one. That's why all these cars will prefer shorter period, they can have charging. And depending upon the free slot, then they can allow the number of cars to be parked. Suppose if this car gets recharged and it can be tracked out, and when any other car wants to recharge, then they can be parked at that slot. So that automation can be carried out by certain people. Okay, which car is nowadays in many of the cloth shops and many of the malls, then this kind of parking facilities available. Hope you all might have experienced. So suppose since this is of solar powered roof, only one slot is there. Okay, suppose if two racked parking slot, then on the top only we can have the solar roof. So we can able to get the power, and then we can have the plugging in the 2-story. Okay, that is also possible. So in that we need to consider the wiring and all. So this is the electric vehicle AC charging equipment diagram. So this is the battery and this is the charger. So, okay, and this is the plug-in area. So here AC alternating current enters into this charger, then that can be converted into DC and that can be stored in this. So this is the device called EVSE. So this is the port which can be called as a connector. So this is industry standard connector port, J1772 connector. Okay. So here this EVSE can be used to do monitoring as well as control. So better for our understanding, we can rephrase, instead of control and monitoring, we can do monitoring and control, because we, the instrumentation engineers, will do monitoring first and then we'll be able to control. So that's why monitoring and control device is there. So here the utility power may be 120 volt AC or 230 volt AC. So depending upon the availability, then we can have. How it is reliable? How it is reliable? That is the biggest question mark comes into every mind. Okay, before using the electric vehicles, we have to ensure the reliability. So electric vehicles can be operated and recharged in all types of indoor and outdoor conditions. Okay, so what will be the conditions such as rain, snow, low temperature, and other harsh environments drivers may encounter. For example, suppose since this is of electric charging, right? Suppose if there is a rain, will it affect the electric circuits? Suppose if there is a snow area, will it affect the if it is of a solar powered charging? Suppose if there is a snow condition, then how will you get the solar power? Suppose if the temperature is very low, that is a purge condition, then what will be the recharging facility? There are so many questions will come into our mind. Of course, all the questions will be taken into account. Then they can able to provide a safe roofing, safe housing, then in order to provide the electric vehicle recharging. So that's why definitely it is more reliable to use. It is proven one. And how do we do charging? So there are three levels commonly used to describe the charging power of the electric vehicle supply equipment. One is the level 1, and second one is level 2, and third one is DC fast charging. Okay, there are three levels. Each and every level can be varying depending upon the power it requires, depending upon the mileage it provides. Okay, so we will see one by one. So this is the charging range added per hour of charging. So if you take the level 1, the miles of range per hour of charging, so this will be minimum. It can be operated with 120 volt. And if you take level 2, then 20 miles per hour of charging, 208 or 230 volts operating voltage. And if you take the DC fast charging, then it can able to provide nearly 73 miles per hour of charging, and it can able to do charging with the help of more than 400 volts, 208 to 400, 480 volts. But nominally, it can be proved that 400 volts can be utilized for DC fast charging. So let us see one by one. This is the level 1, 120 volt charging. So this is simplest form of the charging. It uses a 120 volt AC connection, which can be utilized for standard residential power, residential purpose, standard residential purpose, or certain smaller level commercial purpose. Smaller level commercial purpose. It can be capable of supplying 15 to 20 amperes of current for a power draw usually around 1.4 kilowatts when charging. Okay, so 15 to 20 ampere current, and it can be operated with 120 volt AC. So see, this is the charger. Okay, it can be equipped with a certain manufacturers with the portable level 1 charger. So this is the level 1 charger. Wherever we need to recharge, then we can able to use with the level 1 charger. So this is the simplest level 1 charger, but it can able to use only with low level voltage. So we can able to say that this is the slowest charging. Okay. But if it is of a home level, since the capability of our electric vehicles is not so advanced, then we can able to use this level 1 porter for recharging. That's enough. And this level 1 charging, AEVs with 60 to 80 miles of range will require 10 to 14 hours for full charge using level 1 EVSE. Okay, so this is very important when we would like to consider the charges level 1 and level 2 and DC supercharging. Then we have to identify how long it takes to have complete charging, full charging. Okay, so suppose if we use the level 1 charging, then it takes 10 to 14 hours for a full charge. Okay, so almost nearly half a day, more than half a day. And with full charging, then we can able to ride the vehicle with 60 to 80 miles of range, definitely. So advantages, when we list the advantages, low installation cost and low impact on electric utility peak demand charges. So that's why every it is we can that is we can use this level 1 charging electric cars. Okay. And second one is wherever there are advantages, definitely there will be drawbacks, disadvantages. Of course, we have already mentioned that it takes 10 to 14 hours. So because of this more number of the hours required for charging, we can say charging is very slow. It can be around 3 or 5 miles of the range added per hour of charging. Suppose if you do 1 hour of charging extra, then we can able to add 3 to 5 miles. Okay, so no need to wait till the entire charge is drained. Suppose if possible, we can able to add charging similar to our cell charges. Okay, suppose if you have minimum charging, suppose if you want to fill it up, then we can add. So even though this is slow, then around 3 to 5 miles of range has been added if we provide 1 hour of charging. And coming to the next one, level 2, this is 240 volt charging. So this is a middle range. Okay, middle range. Level 2 charging, it requires 240 volt AC power connection, and it significantly reduces the charging time. Okay, and the users commonly use 240 volts power for some electric cloths, dryer appliances, and many commercial customers have three-phase electric service with 208 volt power. Okay, and this requires three-phase electric service, and we have to better we can use 240 volt power than 208 volt power. In India, we can have 230 volt power. Then we can able to do recharging with the supply of 230 volts power, and we can able to perform level 2 charging. And with the help of level 2 charging, we can able to provide 60 to 80 miles of range. And in order to drive the car of 60 to 80 miles of range, it requires full charging within 3 to 7 hours. So see, in the previous one, it took almost half a day, nearly 14 hours, double the hours. But here, if you choose, this is about 50%, 3 to 7 hours itself in order to complete full charging with the help of this. And we can able to increase the number of hours also. If you take this 60 to 80, same mileage range with 10 to 14. So here, same mileage range with 3 to 4 hours. Okay, and depending upon the capacity of the EV ST and the vehicle charging system. And EVs with smaller level batteries, such as plug-in hybrid electric vehicle with 10 miles of range, it may require less than an hour to reach full charge. Best one is Toyota Prius. So suppose if we have this PHEV with 10 miles of range, then we can able to add full charging within an hour. Okay, so that is the biggest advantage of the level 2 in comparison with the level 1. And this is about the level 2 voltage charging. So this is the charging station, and this is the connector J1772. So this standard connector, it may be used by almost all the electric vehicles. It can able to provide up to 80 amperes of current, nearly in order to drive 19.2 kilowatts. And it can able to use up to 30 amperes for 3.3 to 6.3 kilowatts charging. Okay, and this is about the 208 bar 240 volts charging. This is the charging ports and stations. This is the second one. So anyone can adopt this level 2 in comparison with the DC fast charging. If it is of a home like smaller area, and if it is of smaller level cost, then anyone can adopt the level 2 charging. And these are all the advantages. In similar to level 1, we can have many advantages. Charging time is somewhat faster than level 1. And EVs will get between 10 to 20 miles of range per hour of charge. Suppose if we want to add some charging, then depending upon the hour of charge, suppose if we do 1 hour of charging, then we can able to extend 10 to 20 miles. Okay, and more energy efficient than level 1 for short duration charge events less than an hour. Okay, there are many manufacturers can use this level 2 for different products and for distinct markets as well as requirements. Many requirements, they can use this level 2 charging. Okay. And this is about the level 2. And wherever there are advantages, there will be disadvantages. So because of this higher level than level 1, somewhat installation costs are higher than level 1 and are highly variable depending on the equipment and the installation issues. So what purpose we are using? So depending upon the design of the equipment, requirement of the application, then we can able to do installation. Okay, so for which the cost may vary according to the size and the type of the application. And potentially it can have higher impact on electric utility peak demand charges. So somewhat charges are also high enough for using 240 volts charging. So here I would like to tell in terms of the India users, so for which then we can better to prefer 230 volt charging. And coming to the third one, this is the DC fast charging. So DC fast charging equipment, it delivers high power directly into EV's battery system. It enable rapid charging. Okay, suppose if we want to do immediate charging, rapid charging, then it is better to prefer the third one. So as I already mentioned during the biggest mall recharging with the snapshot, right? So here this is the superchargers, okay, which is otherwise called as superchargers or DC fast charging equipment. It can able to deliver high power. So without any conversion of AC into DC with the help of rectifier, it can directly do conversion and it can do charging of the battery. And typically 80% of the charge can be provided in 30 minutes or less for many all electric vehicles. In many electric vehicles, suppose imagine that there is a parking slot in which we want to do charging of electric vehicles. If the vehicle is standing for more than 2 hours or 3 hours, then it can take more charging. Okay, it can take more power, etc., etc. There are certain drawbacks. So immediately the businessmen wanted to recharge within a short period. So that's why they have to prefer the DC fast charging than the level 1 and level 2 charging, and for which they can able to give more money for that. Okay, so economical condition is somewhat high enough, but time constraint is ready to pay more economy. Okay, so that's why DC fast charging is more preferred by malls and biggest stations like that. So DC fast charging does not same as J1772 plug connectors as level 2. So here we cannot prefer the standard port plug connector what we have seen for the level 1. So this is the charge connector J1772 connector for level 2, but the same connector may not be preferred for the DC fast charging. Okay, so there are for which separate chargers were manufactured by different users, different manufacturers. Here there are 3 major connectors for fast charging equipment. Okay, by various manufacturers. Cadimo, this is used by Nissan, Mitsubishi, and Kia. Okay, so Nissan, Mitsubishi, Cadimo, and second one is SAE combo. It can be used by American and European makes like Chevrolet, BMW, and Mercedes-Benz. And the third one is Tesla supercharger, and it can be preferred by means of Tesla Model S and the later vehicles. And now Tesla has announced an adapter which allowing their owners to use Cadimo equipment also. Okay, so this is a supercharger. Since Cadimo is somewhat less in cost, then there is an adapter required by this supercharger. So Tesla introduced an now adapter which can be allowed to use the Cadimo. Okay, so this is these are all the 3 chargers. So see, this is about the first one, EVSE and SAE. Cadimo connector. This is about the Cadimo connector, and this is the SAE combo. So this kind of connector is to be utilized in the electric station, charging station. So when any electric vehicle wanted to do recharging, then we have to go nearby this station and we have to plug in, and then automatically within 30 minutes full charging will be carried out. So that's why this is the advantage of the DC fast charging, okay, with the help of the super specialty connectors. So there are certain advantages. Charging time is somewhat reduced drastically, nearly only 30 minutes for 80% charge. Suppose if it is of 45 minutes, then we can have the 100% charge. Okay. So why I'm saying instead of 100% charging, suppose within 30 minutes, then 80% charge is more than enough to ride a car without any struggle. Then we can have almost more mileage. And there are certain drawbacks, of course. So we all know, because of the supercharging, the cost will be higher than level 1 and level 2 charging, depending on the equipment and the power availability at site. Okay, so it is very tough to invest this DC fast charging station, because the CADIMO and SAE connectors, adapters itself high cost. So ordinary charging station may not be able to invest these chargers, adapters. So that's why we can have high level charging station with such adapters. So for which cost will be equipment and installation cost will be somewhat higher when compared to level 1 and level 2. But once it is invested, then definitely it won't be a bigger problem for maintenance. And the potential for increased power, peak power demand charges from the electric utility. Of course, wherever we are using the fast charging, the cost will be high enough. So competing standards are still confusing to EV buyers and charging station operators, and potential issues with the cold weather operation requires increased charging time. Suppose if there is some weather condition, then the charging time may be extended from 30 to 50 minutes like that, okay, depending upon the weather condition, whether it is a cold weather or hot weather. Suppose if it is a hot weather, no way to have such issues. Suppose if it is of weather is so much cold, then definitely there may be certain struggling, okay, in having the charging. So when we look into the disadvantages, when compared to advantages, these drawbacks are somewhat minimum. Okay, so when we consider only the charging with less timing, definitely we can adopt the DC fast charging. Definitely it is somewhat economical. I hope DC fast charging will become the potential usage in the upcoming years, and we can, once mass people can utilize this kind of adapters, and if there are so many number of these stations placed for the consumers purpose, then definitely somewhat it will be, the cost will be reduced. And coming to the battery, because electric vehicle battery is another topic. So we want to know the major parts of the electric vehicle. So what type of electric battery and what is the purpose of the electric battery, what it does. So all these things we need to know. So one of the key elements of the electric vehicle is of course a battery, because the battery itself stores the charge and it delivers the power to the electric vehicles for riding. And energy density, we all know, it is a measure of how much energy a battery can hold. Okay, so here the capacity of the battery, which can be defined by means of the electric density. The higher the electric density, longer it will last before needing to be recharged. So when any battery has higher energy density, then definitely it can have longer lifetime. So it can able to do recharging for longer period. And the next one is power. Power is the rate at which energy is utilized. And another terminology is power density. Power density is a measure of how much power a battery can deliver on demand. That is how quickly it can release its energy, or how quickly it can be recharged. Even though we are providing certain high quality electric battery, suppose if there is a less capability to get it stored, okay, get it recharged, then its power density is somewhat minimum. So we have to ensure the electric vehicle battery which is of higher electric density as well as power density. Power density should be high enough and electric density should be high enough. And there are so many types of the battery in usage. One is the lead acid battery, and second one is nickel metal hybrid, and third one is lithium ion, Li ion. The fourth one is lithium polymer, Li poly, and lithium ion phosphate, LFP. So these are all the various types of the battery. They have experienced, they have started in use, and they have done research with the help of all these types of the batteries. How long it takes to store, how long it takes to recharge, like that. So among all these five, the most preferable thing is lithium ion battery and lithium ion phosphate battery, LFP. Okay, so before getting into the usage of this thing, then let us have some of the terminologies. First one is state of charge, because all these things are very important when we choose a type of the battery. First one is state of charge, SOC. So battery capacity, it is expressed as percentage of maximum capacity, which is otherwise called depth of discharge. The people who are from electrical background or mechanical background, when we are using this kind of battery, then definitely we have to ensure all these terminologies than any IT persons. Okay, so this is called depth of discharge. DOD must be defined. And next one is the percentage of battery capacity that has been discharged. It can be represented as the term called capacity. So how what will be the capacity of the battery? Okay, how much percentage of the battery condition is there? So we have to ensure. And the total ampere hour, which is available when the battery is discharged at a specific current from 100% SOC, it is called thing. Okay, and the next one is total watt hours, which is available when the battery is discharged at a specific current from 100% SOC. And specific energy, total watt hours per unit mass is specific energy, and specific power, maximum power watts that the battery can provide per unit mass, function of internal resistance of the battery. So we have to consider depth of discharge, capacity, energy, specific energy, and specific power. So when we would like to buy any of the domestic appliance, definitely we, the people from our discipline, then we have to look into what is the power rating, what is the horsepower, all these things we will look, current rating, everything. Similarly, when we would like to buy this battery, then we have to look into all the terminologies. Then we have to ensure whether it can be suitable for our battery. And specific attention to the electric vehicle motors compared with ordinary industrial application motors. It requires high rate starts and stops. We know some of these motors can also be applicable to some other industrial applications. Okay, so industrial application motors, we can have certain types of motors, so that these terminologies may be suitable for that motors too. But in comparison with these industrial application motors, when we choose the motors for electric vehicles, then we have to consider all these things, whether it can able to provide high rate starts and stops, okay, and high rate of acceleration and deceleration, and high torque, low speed hill climbing, low torque, high speed cruising, and wide speed range of operation. So all these are the requirements when we do select the EV motors for our electric vehicles. Okay, so electric vehicle battery, which is a battery used to power the propulsion of battery electric vehicles. So this is a battery electric vehicle. That's why it can be represented as BEV. So vehicle batteries are usually rechargeable battery. Okay, so it cannot be, it should not be used and throw one usage. So it can be rechargeable. Once its entire charging is draining, then we have to do recharging. So rechargeable batteries used in the electric vehicles include nickel cadmium and nickel metal hydride, lithium ion, a lithium ion polymer, and less commonly zinc air and molten salt batteries. There are various rechargeable batteries in usage for electric vehicles, and most popular battery is lithium ion. Okay, lithium ion battery. This is most important thing. So, but lithium availability in Indian subcontinent and is dependent on import from China, Japan, South Korea. So there is a need to have some alternate technology. So lithium is not much available at our India. So it can depend on other countries like China and Japan and South Korea. So we are in need to import from these countries. Okay, so then only it can be utilized. But when compared to cost one, lithium ion is somewhat economical one, less economy. Okay, so minimum cost when compared to other things and easy availability in such a continent. So that's why we will prefer the lithium ion for the electric vehicle battery. And due to the easy importing of this lithium from these subcontinents, then we can have the usage of the lithium ion. Okay, this is about the electric vehicle battery. This is about the rechargeable secondary battery parts. So this I don't want to explain all these things. So see, just I want to expose the snapshot of the internal battery parts. So there are certain insulators, center pin, anode container, cathode, and anode lead, anode. This two are the will be separator. And there will be PTC and vent and cathode lead and cathode cover, gasket, and certain insulation parts. So these are all the various parts of the various parts behind the lithium ion battery. Okay, these are the rechargeable battery parts of the electric vehicle battery. So, and all the batteries have depth of discharge DOD beyond which its life is somewhat reduced. And most of the lithium ion batteries, the DOD is 70%. So, depth of discharge, okay, depth of discharge is 70% maximum. I can give an example. Suppose 100 kilowatt hour battery should not be discharged below a residual 30 kilowatt hour level. Okay, and if it is of drainage, completely drained, then there will be some more difficulties. Starting trouble. I hope many of you might have experienced with our conventional car battery level itself. Suppose if our car gets not started, then immediately then we have to check into the battery. So our battery may be drained completely. So once it can be charged and it can be placed in that car, then we can able to start. Am I right? So that's why then we have to ensure the at least the minimum power to be there in order to start. Okay, so that's why it is very important to mention the depth of discharge as 70%. And as the residual power in the battery decreases towards the DOD levels, the stress on the battery increases. The state of charge 100% of the battery is the opposite concept. Okay, suppose if the it is equal to 100% when the DOD is 0%, and it is equal to 0% when the DOD is 100%. This is about the state of charge, just inverse of the DOD. SOC is the inverse of the DOD. Okay, so if the DOD is 100%, then state of charge will be 0%. When the DOD is 0%, then the state of charge is 100%. So we have to mention both SOC as well as DOD for every electric vehicle battery. So this is behind the electric vehicle batteries. Okay, so in any of the charging station, any of the electric vehicles, the charging is fully depending upon the capacity of the battery, how much charging can be adopted by the battery. Okay, what is the capability of the electric vehicle battery? Even though we will be able to provide the supercharging or DC fast charging, if the battery provided in the electric vehicle is not that much of capability, then it is no use. We cannot help. Okay, so that's why the electric vehicle battery is placing a major role, vital role to get the recharging of the power. And this is how the solar powered EV charging. So there will be several panels. So those panels have been integrated. So this can be of biggest roof. It can be treated as a roof, and it can have certain tracks in which then we can able to park the cars. So imagine this is about the solar powered electric vehicle charging. Okay, it's the cars. So when we park the car in that mentioned slot, then the plug-in facility available at that slot can be utilized in order to do charging. So once this is a solar powered charge which can able to provide with DC fast charging, and then we can able to do. Since it can able to provide with storing capacity, then because of the huge solar powered panel, then we don't have any struggle during the snow condition or rainy condition. Suppose if it is of a single rack of the solar powered panel, then it may be a problem. But here we can have many number of multiple panels. So definitely the capacity of this panel will be high enough, and for which it can able to supply power to recharge the electric vehicles in many number. Okay, more number of the electric vehicles can be charging at a time. So that is the advantage of the solar powered electric vehicle charging. So the charging stations can also be powered by the solar energy. Number of solar panels can be placed on the roof of the charging station. It can able to deliver power to the charging point. So use of the solar will reduce the load on power grid and will also save considerable amount of the fossil fuel used in the providing electricity. So these are all the advantages of the solar powered EV charging, and it can able to provide environmental user friendly environment, okay, pollution free environment, or that's why then we can provide, and the power will also be utilized. It's a renewable energy source. Then we can able to save more power, and more cost will be reduced because of the solar powered charging. But only one thing is due to which installation cost will be somewhat rich, and we need to do maintain at frequent timing. Okay, so up to this I would like to stop, because the topic will be of next one is location selection and siting criteria. So that I will take during the afternoon session 2 o'clock. So any doubt? Shyamala, shall I stop this, because the next topic I want to provide more continuity. So that's why I would like to stop up to this.
Yes, madam. Okay.
Okay, so let me answer for the queries from our participants.
Ma'am, are solid state batteries a good choice?
Yes, ma'am, maybe, definitely.
Okay, thank you, ma'am.
Sir, any other queries?
Hello, madam, Dr. Gauri, madam.
Yes,
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 sir.
sir, please.
We want PPTs of all the sessions.
Yes, sir.
So
I will collect from all
yes.
the resource persons, sir.
So it will be definitely supplied by the coordinator, sir. We will hand over the PPT to the coordinator, and
Okay.
madam will definitely provide the PPT to all the participants.
Because these are very useful and very
Okay,
nice.
sir,
Therefore,
okay.
yes,
Thank you.
it will be helpful for us.
Sure, sir, sure.
Okay. Thank you, madam. Thank you.
Thank you, sir. Ma'am, we will wind up the session, ma'am.
Okay, madam.
By 2 o'clock again, we will join for the next session, ma'am.
Sharply 2 o'clock I will join. I request all the participants to join sharply. Thank you.
Thank you, ma'am.
Thank you.
Uh,